We're going to look at trig identities. An identity is an equation where it's true for all values of x. Sometimes when you look at identities we use 3 equal signs instead of just 2 to show that it's exactly equal to. The first identity we're going to look at, consider a right angled triangle. Give one of the angles the name x, and therefore the angle at the other side must be 90 minus x degrees. Labelling the sides A, B and C, I can see that sine of x is equal to a over b. By the same method, cos of 90 minus x, the other angle, is also equal to a over b, because cos is adjacent over hypotenuse. So that tells me that sine of x is the same as cos of 90 minus x. There we have what we call a trig identity. If that's true, then therefore it's also true that cos of x is equal to sine of 90 minus x. Those are your first identities. The second of our basic identities, let's go back to considering the same triangle again. So we've got a right angled triangle, sides A, B and C, one angle x degrees. I can see from this triangle that tan x is equal to a over c. Also, cos x is c over b, and sin x as a over b. Using these fractions, these ratios of sine, cos and tan, I can manipulate them so that I can see that a over c is the same as a over b times b over c. Think back to when we did rates of change and related rates of change. The same idea applies. Where do those come from? Well, a over b we've just said is sine x. B over c is cos x but inverted, so 1 over cos x. So therefore a over c is equal to sine x divided by cos x. That gives us the identity of tan x, which was a over c, is equal to sine x divided by cos x. And that's our second identity. For our third identity, I'm going to use the same thing again. I've got a triangle, label angle x, two sides A and B. Just this time, I'm going to call the third side the length of 1. So, looking at those ratios, sine x, I can see it's a over 1, which is just a. Cos x is equal to b over 1, which is just b. Thinking back to Pythagoras for right angled triangles, I can see that a squared plus b squared must equal 1 squared, 1. So substituting those things back in again, if sine x is a and cos x is b, I can write that equation as sine squared of x plus cos squared of x is equal to 1. Notice that when we write sine x squared or sine squared x, the squared goes between the sine and the x, not at the end, so it doesn't look like sine of x squared and isn't confusing. That's our third and final of our basic identities, sine squared x plus cos squared x equals 1. Those 3 basic identities are used to derive a whole load of other identities that we'll look at next.